Agora a segunda parte do X Fórum 17.
The second
Now,
part
at the
of
second part of the
IX17, I'd
IX
like to
Forum
invite
17,
José
I
Eduardo
would like to
from
invite José Eduardo from FiberX to talk about the evolution of networks.
Por favor.
And he's going to talk about DCI, the evolution of DWDM networks.
Opa, boa tarde a todos, pessoal. Agradeço pela apresentação. É uma honra grande participar, né, de ser
It is an
expert da nossa
honor
comunidade.
to participate in such an important forum.
Acredito ser de boa relevância, né, que é como otimizar o uso
And
das
I
redes
think that this
óticas.
is very
Primeiro, eu vou
relevant, how to
introduzir
optimize
a tecnologia
optic
DWM, que é a tecnologia
networks. So
adaptada
we
ali
are going to talk
das
about
redes óticas, tá? Bom, pessoal,
DMWM.
como vimos no começo da manhã de hoje, também falamos um pouquinho aqui no finalzinho da manhã sobre os data centers,
At the end of the morning, we talked about data centers, and the traffic demand keeps growing. We need technologies that can absorb these traffic demand. And DWDM is a mature technology that has evolved significantly, always with something new, trying to optimize the use of physical and optic resources such as space and power. We also try to optimize human resources as well. So we constantly focus on simplification of our operations. I divided my agenda in 3 phases. So challenges for POP connection, also a DCI solution, which is one of the evolutions of the DWDM network. And I'm going to tell you where it fits. And I'm also going to give you an overall summary of the DWDM evolution. So in solutions with switches, you might have a small region that I can use with a small point of presence, which we call site. As we grow, we will cover more neighborhoods, more cities, and I will have networks that will look like this. And then I get up to the threshold of the interface. There is more than an option here. One of them is just acquiring more optic fibers. So you might have just one connection and you might have more than that. What are the potential difficulties in this case? If we consider to use more fiber, you could always build it. There are legal requirements to be met. You can also swap with the different operators or maybe rent the network from an operator, from a carrier. And of course, it is difficult to predict how long it will take until you can actually increase your capacity. And of course, you cannot wait sometimes because your need might be immediate. If you have different partners, different type of fibers and different types of rent agreements, it may be difficult to manage all that. Sometimes it is difficult to maintain a network like that. So how can we solve that? DWDM is one of the technologies available. This is as if you had a highway and you're increasing the number of lanes because you already have the infrastructure, but you're increasing the size of fiber exponentially. One single fiber can carry up to 120 wavelengths. So the optic structure sometimes is no longer the bottleneck, but the time it takes for you to expand your network. So these deadline is more controllable. Maintenance becomes easier because there will be fewer different resources available. It might be, the operations might be on your own hands. So ultimately, you can also recover your investment quicker. On this slide, I would like to remind you how the DWDM technology works. It involves different components that are customized according to the needs of that particular route. We can call them sub-technologies. So the point where I get the signal from our switch is what we call the light emitters. This is what a transponder is. And then you have the multiplexer. You have different wavelengths that will be carried on the same fiber optics. And when it gets to the destination, then there is the opposite of that, which is the demultiplexer. Networks are usually designed to take long distances, and the next component of this traditional solution is the optic amplifier. And finally, the last component of the WDM system is the supervision channel. It runs on parallel to the main system, and you can monitor and control the system using that channel. You also have a plate, which is another multiplexer that is installed at the end of this network. So thinking about this traditional WDM solution, in each component, you will have sometimes a board that will play the role of a multiplexer, a board that will play the role of a transponder, and then we need to take into account how much space that will take in your system. This is a bidirectional system, and there is a set of boards to cover one direction, another set of boards to cover the other direction. And that will basically take half of a rack and would take a significant amount of energy. So this is a summary of the barriers we face when we implement WDM solutions. That solution involves several components and its installation is rather complex. For every connection you see on the slide, you will have an optic fiber. So depending on the inlet and outlet point, you need to also establish a jumper connection. There is a high number of optic connections to be done on each side, so you have different interconnections. Usually, you will need a specialized team for the commissioning of the system. Once it is implemented, I also need to make sure the system gets proper maintenance or sometimes get expanded. So we need a specialized team for that. So you have one expert in routing, one expert in OLTs, but we not always have an expert on transmission. And to operate the system, sometimes it's a little bit difficult, and maintenance can be difficult as well. So what are the potential solutions for that? One of that is the data center interconnection solution, DCI. This is one of the evolutions of the DWDM networks. What are the main requirements for a DCI solution? It allows high integration. With that, you can save space. It provides low energy consumption. It provides flexible expansion. And the O&M is simplified. Of course, the implementation is also easier in the case of DCI. It has embedded AI and it self-configures itself in different scenarios. So basically, it's a self-setup system. It's plug and play. Anything that is new will be plugged and automatically recognized by the system. It's an automated system, as I mentioned. Not only commissioning is simple, but it also provides reliability. These devices meet all the demands of a data center requirements, so encryption, hardware, network protections. For maintenance purposes, of course, you also need simplified operations and management, and DCI solution is a simplified system. This is one example of the data center interconnection. Two U racks that are modular, and they fit perfectly to the data center rack. Equipment follow a telecom standard. It's very robust, but usually emits the requirements of telecom. But for DCIs are more indicated for data centers, considering the cold and warm corridors, considering all the cooling requirements, because as we saw in the morning, there are a lot of cooling requirements when it comes to data centers. Simplification is important. If it is on a website, okay, so what type of supply system you have? Is it DC? Great. Is it AC? Great. I can connect to either one. This is the second generation of products, and DCIs can also have an embedded optical layer. In the tradition DWDM, there was a 40-channel MUX multiplexer, and here we can have up to 60 channels. We can also have a supervision channel, but everything is embedded in one single board. So it's a simpler solution. It does not take a lot of space. And you can also have MUXes with fewer channels. So not just you have the optic layer, but it is smart. It plays different roles in one single hardware. You may have MUX, you can have an TX, RX amplifier, the supervision channel, and its board. And all of that is built into one single hardware piece. We also have a MUX with 40/60 channels. It can take up to 120 wavelength, 24 terabytes in a pair of fibers. So a significant capacity for transmission. It can be complemented with a second board, with two amplifiers, supervision channel. And so the optic layer is very good for DCIs. We call them the transponders, the electric layer. But here in DCI, you have both. You have an transponders of 200 giga, or maybe with various various access ports. You can integrate different systems, 400 giga transponders. There are two models of those. And we have the Super 300 and Super 400 giga transponders that can take the signal for up to hundreds of kilometers. This is a simplification system, and in the embarked software, you can upload it, you can configure that, and you can monitor the network, not just the rack. So you do not need a server of up to 20 boxes. With a local software, you can monitor a system like that, and it will be a simplified version for a day-to-day operation. This is one example of a DCI configuration. It's a modular equipment. So optic fiber to different routes. So one optic fiber that takes 2 slots, one MUX that involves amplifier, supervision channel, and 4 200 giga transponders. We can reach up to 1.6 tera. A MUX of 8 channels could be a simple solution, but still the capacity is very good. It's the connection of the main sites of data centers. This is basically a summary of the DCI solution. So let me tell you about the evolution and what is already available in the market.
Well, DWDM, how to evolve them? We may either increase the number of layers or we may increase each one of the channel's capacity. Here are some examples as how we are doing as to the traditional model. Before, they would occupy band C, where we would have 80 layers of 100 gigas. Today, we may apply Super C layer. We had switched from 4 to 6 tera. This we can see here a leap extended 6 band, a total of 120 wavelength, 8 or 6 layers of 800 gigas, a total of 8 tera. Well, we have clients that are talking about this capacity. We have a optical fiber which is ready to comply with 60 channels. Well, what is each one of the layers capacity? 200 giga with the modulation QPSK, band rate 69. There is a balance between the capacity that you may apply to the channel with its space. The higher the capacity, more dense the optical spectrum. So we try to reach a balance to optimize the channel's resource. If we have a spectrum, a channel with a very large spectrum, that may end up hindering the channel capacity. So here there is an example of 200 giga or 75. In real life, we may have a lab distance that may be longer than 3,000 kilometers. This is ultra long haul and long haul. Less space, I may implement more channels, 400 gigas, 75 gigahertz, and super 400 gigas. In practical terms, we may implement networks with providers small, middle, and large size, and also 600 giga with the same modulation, but shorter distances. The denser the modulation, more sensitive to the need to signal-to-noise ratio. 800 giga, today metropolitan. This is the current scenario, but there is a roadmap for the coming year where probably the 600 giga will have the 400 capacity. So we stay tuned to the novelties. Hardware evolution, what have we got? Even the traditional DWDM systems, we see features being condensated on one single slot. Before, we would have a TX amplifier, a plate, you name it. Now, we have just one plate where we can have all features. We are able to customize all amplifiers. So in the same hardware, we have an adapter, and we may have several amplifiers. DWSS, 20 different directions. We can, set to 20 different directions, and that hardware with 5 different features in the same plate. Now a TX RX amplifier. So in one single slot, we are able to have several features. OH20 has got 5 slots, and that used to be 6 before. If we have a new provider with more coverage, fine. And here a different example, which is a provider with a greater coverage, a hub type. São Paulo is the main hub, and I connect to Tier 1, IX, and my coverage is a state-level coverage type. I have listed some main states of the São Paulo. This slide shows step by step of DWDM network. Usually that is born with a fixed WDM. Each portal has a fixed wavelength. I can start with the main feature, ODM type, with 2 generations. Let's say that I have to take something from point A to point B. If I go with a second layer, I have a second prefix. So we call them as fixed terminal. Each one of the traffic passages, we have a terminal. For directions, will be feasible to take this website to a more advanced direction where RDM, WSS, wavelengths selection. Any wavelength can be added to any port. With that, a wavelength that will go from point A to point B can be easily set up. However, channels that will start on point A are fixed. So they will have a fixed length as to wavelength and also as to the direction to be followed. A transponder can just follow one single direction, respecting one single wavelength. So we have a site with more directions, which will require more directions and more flexibility. Next step, this is a colorless and directionless concept. What are they? I may have at the end drop point an SS. Any wavelength may get in and get out, following any direction, because the WSS will be at the add drop. Each wavelength will leave from different inputs and outputs, and the drop is still the bottleneck. There is a certain wavelength that will follow a certain direction. Let's say that I want to use the same one in a different direction. This is the next evolution level. There is the contentionless, colorless, directionless, and contentionless. 9.10 tera. If I want to throw 9.10 terahertz from one position to another, that's possible thanks to contentionless. That will solve the add drop feature. What else? Each one of the directions, they represent one plate. Next step, cross-connect, where we eliminate all connections, and the connection between add drop is done throughout the back premium. There is no need to go through all those jumpers. So we have different plates to each one of the directions. Usually by default, to each direction, we use one full rack, which is replaced by one single rack, as it is one plate. And the jumpers that we had linked all the directions, they are no longer necessary. They are in the back training, all plates of the system. They communicate throughout the back planning. I no longer have 32 sub-racks, and I had replaced that for half rack. This is a very interesting solution. How does that work? I have two types of racks and frames. To each one of the lines or directions, we have a line plate, and to the add drop, we have a portal, and they talk through the back plane. All different directions, they are all intertwined with several jumpers, and this configuration has no other jumpers, no optical fiber. In our production line, we have two compact boxes and a larger one that is the traditional size, and two unit types, the line plate and the add drop, where we upload and download the channels. There were 17 directions in the prior example. Well, let's say that I have to work on an additional entity. Then I have just to add a plate, and then I will add this extra city that I have to evaluate, and all other destinations and directions will be able to walk one to another. WDM and all this board issue is a topic that would require, the whole afternoon discussion. But if you have any further questions, comments, please just talk to me. I'll be available throughout the day. Thank you.
Obrigado, Zé.
Thank you. We have a question. A question from a participant at YouTube. Could you elaborate if the solution has an affordable price for sub-cables, underwater cables? Yes, it is very competitive in terms of price. Similar to the land solution, the whole underwater configuration, they will be kept. The only thing is that the fitting of those amplifiers throughout the route, they will be maintained. But now the land fix, we have several concentrations and different destinations. Let's suppose that we have an optical fiber from Rio de Janeiro, São Paulo, just in another city, just two directions. Well, that's more affordable. But if we would need multi-directions, and here I'm talking about 7 or 8 directions, we will need something else, a site with the OX, it's worthwhile for a multi-directional site. I don't know if there is any question from our audience. No questions? Okay, thank you.
Dando sequência agora às nossas apresentações.
Next in our agenda, I would like to hand over to Jesaída Arruda from Bemol. He'll talk about new technologies which will impact digital inclusion in the Amazon region.
Esse painel cego aqui, quem está me ouvindo, levanta a mão aí.
Can you all hear me all right? Yes, we can all hear you. My name is Jesias Arruda. I work for Bemol and also I'm VP for Abranet. It's a great honor to be part of this event. I promise you now that we are going to talk about a very interesting and different topic. Addressing new technologies which will impact the digital inclusion in Amazon is always very challenging. This is one of the regions that are the most challenging ones to undergo digital inclusion or inclusion as a whole. Connectivity is a very hot topic nowadays and a great challenge, consequently. What are we doing in the Amazon region? What can we do? What can be improved? Let's see. This is a beautiful picture from our river. We had the worst drought in the area, very dry weather. Some cities, they were with no physical access or whatsoever for more than a month because the river got totally dry. These villages, they have no airport, no inclusion or whatsoever. This is a city from Manaus Harbor where you can see an empty river. This is our harbor there. What you see right now, the river was like 60 meters away, very, very low. Most of the vessels, ships, they could not stop at our harbor. The main transportation mean in our area are our boats, and they couldn't navigate throughout our rivers. Who come from the northern region of the country? Fine. So you know that we have a total of 450 municipalities just in the state of Amazon, 62. And out of those 62, you can just reach them by road, all the rest just by boat. Last year, in the infrastructure week, it was shown that the northern region, 20% of the whole northern region had no connectivity at all. And connectivity, internet, you name it, they had experienced a huge boom. How about living on a city with no connectivity? How can you reach indigenous and native communities which are not connected? To each city and each village, we have communities surrounding them. I mean, there were challenges with the optical fibers, and today there are internet providers that they may release fibers over the top of the trees and also along the rivers. Is this a project called Gel Connected Northern? No, this is a different project. Many people will say, well, that does not work. Fine, but our goal is to allow inclusion to those remote communities along the rivers. With that, we were able to implement Starlink wires. Starlink, it's quite polemic to talk about that, but to be honest, let me tell you, innovation, goes behind the demands and the needs. If you have needs, you try to do your best to reach areas where you wouldn't be able to go before. Now we are here on a room with all connectivity, 4G, 5G. But how about those remote areas with no connectivity at all? Well, now we are talking about challenges. All pictures that you are seeing now, they are real life pictures. This is an indigenous community based on the state of Pará. And 1 year ago, they were blessed with this Starlink wire for communication purpose. They placed it, they installed it in a health station, and now physicians, they are able to access other physicians for telehealth consultation. 200 schools in the region, they also got those wires for connection. Before, schools, they were not connected at all. Teachers, they would not have access to internet. But now, and even though 20% of the region is still have no connection, but others now they can, access internet. That is part of a joint effort by the public and private sector as well as third sector. Everyone is trying to bring connectivity to the region. And how come there are so many obstacles? Why do we use Starlink instead of optical fiber? Why do we place satellites instead of radio? And why 3G or 4G instead of broadband? Well, simple answer. It has to do with geographic distances. How can we connect regions or communities which are so remote? They might be 80 kilometers away and they are very remote where there is nothing at all. They are, in the middle of the forest. And I'm not talking about, in the middle of the bush. They are like in the middle of high trees, deep forest. And how to take energy to those regions, and by that I mean not just the northern region, but also northeast. They are very challenging regions. The day before yesterday, the state of Roraima spent 12 years with no connection at all. Why was that? Because the only connection that links the state of Roraima, it goes through Amazon, the state of Amazon, and the BR, which is the road, and that cable was with no connection throughout the whole day. And when I say no connection, I mean not just internet access, but I mean no telephone, no banks, no ATM, no cell phone, nothing at all. High contingency. What to do? You may either use a satellite internet connection or you have to wait, and be patient. We are in 2023, and yet the state of Amazon didn't have internet connection for more than 20 times for different reasons.
Sometimes there is a link of one carrier that is broken, but the other carrier cannot provide backup to a piece of equipment in a state that is really far away from us. And they suffer this impact as well, because connectivity today is still linked to what you have at hand. So what have we been doing? We've been using a satellite network. We use that, but not as often. But now we are using that more often. This is one example of the schools. So here you have a speedboat where that can take up to 100 people. This is called a jet. It's called a jet speedboat from Manaus to Tabatinga. In a traditional boat, it would take 8 to 10 days, but it takes 36 hours on a speedboat like this. Can you imagine that you didn't have any internet connection for 36 hours for your cell phone or for your laptop? People look at me and say, oh, there's no possibility that that happened. Well, it used to be like that. You'll be on 36 hours traveling down the river with zero connectivity. And sometimes there could be another city close by. You could have just a 6-hour trip, but still without any connectivity. And now they found out a solution. They have put 2 Starlink connections on top of the speedboat. Now they charge a little bit higher ticket, and you can use WhatsApp during your trip. So what this company is doing is opening a new business niche. This company is connecting people, using that as a competitive edge. So competitiveness is not just about connection. It can also expand businesses. Connectivity can bring a whole different reality. So the speedboat is just one example, but other companies are doing similar things. So, for example, a satellite internet of Starlink reaches 100 schools in remote areas of the Amazon and of the state of Amazonas and Pará. This is a small speedboat made of aluminum. It has an engine in the end, and on the front of these boats, you see a Starlink antenna on a framework. Any type of information that is necessary is being carried using this solution. Of course, there's so much more that can be done. For example, the prosecution's office can also make better operations because now they have internet connection through satellite, because you wouldn't have access through by telephone very often, depending on how remote the areas are. And now you have police operations using speedboats that have Starlink connection. Everything is done. So all types of police forces, law enforcement agencies, environmental agencies, all of them are using this type of connection to improve their results. There's no point of return here. There's no turning back. So what are the expected results? Results are obtained by exploring opportunities, not by resolving old problems. Starlink is one example of that today. And I wonder, what will be the next solution that will be similar to that? When are we going to have connectivity of different types? And not just for the Amazon region. This was just one of the main programs that were launched, like a connected schools, also resources that are now being taken to improve connectivity. The government is making investments on that. But how can we change this scenario? We say that the field should be connected. 30% of Brazilian agribusiness is connected, just 30% of it. But our challenge is much bigger. All agricultural machines and devices work better if they are connected to the internet, up to 20% increase in productivity. How is that related to the Amazon? Well, it is related to the Amazon because in the northern region of Brazil, we have plantations and different crops of corn, of soy, of cattle raising, and there is no internet connection in some of these regions. It's not just having connection for the sake of having a connection, but what kind of results can we reap from that? How can I take the next steps and bring more value to what we do? The number of schools that are not connected these days are above 40,000 schools. And some of them, and in the northern region, 20% of these schools in the north have no connection whatsoever to the internet. In 90 cities, there is zero connection. I'm not going to ask you to raise your hand, but I am sure that all of you here have already made some sort of instant payment using your banking system. Can you imagine a city that has no access to instant payments, which is the most traditional way today of making payments in Brazil? And you can say, just Google it. How many cities you cannot say that? How many cities cannot watch a live event like this one? Because they lack connectivity, and we are generating a digital abyss. But each and every one of us can play a role to solve this problem. None of these solutions is ready-made. We need to do much more than that. We need to look at the scenario and we need to feel bothered by that. You who are watching this should be bothered by that, because here we have all sorts of experts, people with technical background, entrepreneurs. So what are we doing to take the next step? This is a headline. This is a boat, a huge iron boat that goes from Manaus to Tabatinga in the northern part of Brazil. And they have a Bradesco bank branch. This boat had a satellite antenna, and it took a long time every stop to align the satellites, and they could make very simple bank operations there. So they replaced this old satellite with a Starlink connection. Now, any community where this boat stops at, a customer can open their bank account, they can download the bank app, and they go into this boat as if they were going into a bank branch. And you might say, well, we no longer need to go to the bank branch as well. That's because you have connectivity on your phone. But if you live in an area that has no connectivity, this is the way to go to the bank. So now these banking branch also counts on this connectivity. Bemon is a retailer. We use Starlink as our main link, our main connection source. It's a retailer store that operates from 8 o'clock in the morning to 8 o'clock p.m. And we use Starlink for everything we do. Is that because you like Starlink? Because you're Starlink fans? No, it's because in some cities in the countryside, you have zero connectivity at least 9 days a month, because somebody just hit into the fiber optics cable, because a tree went down, because the river is empty, or because the forest was set on fire and the fiber optics cable is now burned and needs to be replaced. All of that can cause an impact. With the Starlink antenna, you can just have connectivity. Of course, the amount and the availability is much lower, but the impact is much higher because there is a direct result. So law enforcement agents, police, banks, retailers, all of them are using that because of the needs that we have there. We need to adapt your business to what is available. At BIMAL, we have Open CDM. This is in the Amazonas region, And that was a partnership that started in 2017. I was talking to Moreiras and we came up with a solution. And there's a major impact of that solution in the region. The fact that you can connect the Amazon region creates a great impact. But the connection is different because you need to mix and match solutions. Last year, at one road that connects Manaus to Porto Velho, there was a bridge down 1 week, all cables ruptured. And when we thought everything was solved, then another bridge came down. And now to access some cities that are 100 kilometers from Manaus, that would only take maybe 1 hour in barges and 2 hours on the road. Well, now you cannot take the road. Now it takes 4 barges for you to get there. And I shouldn't fail to mention the project called Connected North. We've been using satellite internet in this project. It had different names in the past, it had different steps of implementation, but right now we have the Infoway connecting Macapá and Santarém, and Infoway #1 that also connects Santarém to Manaus. Those Infoways are ready, the 2 of them. And there is a delay in installation because the river is dry and the barge cannot move. And this is why the project is just waiting for the river waters to come up again. So these projects will have 8 infoways and will cover 12,000 kilometers in the water. I'm talking about rivers here. That entails 1.3 billion reais in investment. 10 million people will be benefited from this project. 59 cities will be covered in 6 different states of the northern area of Brazil, and 68 million trees will be spared because this is not a typical telecom network. It is a network that goes underwater. Of course, it involves challenges as well, and not a few challenges. Making a structure like that to work is crucial. There are difficulties before we install it, and making it work is difficult as well. This is a federal government project. This is a picture of these barge. It's a boat that will release the optic fiber cables onto the riverbed. 12 companies that are working in partnership to use those resources as well. And here is the drawing where the infoways are going to be. This is the northern area of Brazil. This is the state of Pará. Belém, Macapá, Santarém, then Manaus in the state of Amazonas. Then you have Roraima, Acre, and Rondônia. Those are states in Brazil. When the 8 infoways are ready, we will have the whole northern area of Brazil connected. When all infoways are ready, we will feel the impact on the lives of thousands of people. We are talking about a major paradigm shift. The state of Roraima, every time something happens in the state of Amazonas, then the Roraima state is in the dark because of it. It is affected by problems in another state, as if we were living 30 or 40 years ago. And in addition to that, you can also have connected hospitals, connected schools, you can have digital inclusion. We don't talk about internet just for the sake of having internet. We talk about resources. We also talk about what we fail to learn when students at schools have zero connectivity, because they're still doing their homework and watching classes and attending classes like we did 40 years ago. And the teachers still depend on the board and on chalks. and they have no source of reference, maybe books that will be part of a very small library. So connectivity is a concept that goes beyond connectivity per se. We don't talk about that as something simple. We need to understand the purpose of that. We see companies outside Brazil. So we have companies abroad making investments. The federal government is making investments in it. There are projects that involve NIC.br. And when you talk about open CDM and direct access, is the same. So each and every one of us has a role to play, and we can help. I would like to thank NIC.br for the opportunity of sharing this information with you. Thank you.
Isaías, obrigado.
Thank you, Isaias. Are there any questions? Any questions to our speaker?
É isso, né? Isaías, obrigado. Ah, por favor, pode falar seu nome.
Please tell us your name.
Só um minutinho, por favor.
Just a second.
Está ouvindo? Agora estou. Pode falar, por favor.
Okay, go ahead.
O microfone está desligado dele.
This mic is off.
O microfone do centro, por favor.
Oi.
Agora tá.
Me chamo Neilson Reis, sou do...
My name is Reis, and I am a partner of Click IP Group. After listening to his talk, we suffer together as I am a player at the state of Amazon, and we are the third carrier in fixed broadband telco. And in numbers, Starlink has reached over 100,000 customers in Brazil, and we have a great share in the state of Amazon, and they represent 22% of the Brazilian population and 15% of all connectivities, all the active connections that Starlink has in the country. So several cities in our state are not connected at all, unfortunately. An affordable connection can be extremely helpful. And we agree when Isaiah says that now we had exceeded some barriers that requires really hard work. And we, from a private sector, we are doing our best to improve our efforts, such as long distance backbone on a national setting. And our goal is to mitigate our daily challenges and difficulties, despite there are two infrastructures available on the state, and despite having offered by two different carriers in their backbone, we lack of people that will enable it. There is a protected circuit, but if there is any failure in any side of the network, that will reduce in less than half the capacity of the connection. And in addition, there is an absence of capacity protection. We may have a service, but not protection. And if you have no protection, you have no service. So within this urgent scenario, if Isaias could share his experience with those services that we don't have, even though we pay quite a lot for that. What was supposed to be good, as you have two possibilities, two different ways, but in fact, that's not quite what happens in real life.
Pode fazer a próxima pergunta? O Josias já consolida depois.
Yeah, let's get the next question and then he can answer both. Hi there, I am Leo. I'm Leo. Are there in your region any opposite movement? I mean, especially those communities who are in the most remote areas, are they really willing to get connected, or are there those who wouldn't like to get connected, or that would just prefer, to live on their traditional way, with no connection? Can you all hear me? Yes, go ahead. The project Connected North, you told us that due to the dry weather that caused a number of issues. If that insists on happening, will the project be affected at all? Well, I'll try to answer all the questions. The first one, very timely, especially when we talk about connection. There are several carriers, operators, but the second one, which is the backbone, just offers 20%. Shame. And that hinders any sort of business operations. And we have to give a name to those people, call them to a formal discussion. If one carrier stops in Manaus on a Tuesday morning, 10 minutes later, all other 3 carriers, they will also stop due to lack of capacity. And then for 6 or 7 hours, we have no connection or whatsoever. And the state of Roraima is taken with us. And then, we just have to ask for help and not to count on a carrier that says, I have 100% coverage in the country if there is no 100% quality.
Só minuto.
Just a second, apparently there is a technical issue in the room.
Ouvindo?
How about now? Can you all hear me?
Não está ouvindo. Não está funcionando, não está.
There is something wrong with the audio in the room.
Não. Tá. Não tá, não tá. Agora tá? Obrigado.
Oi, estão ouvindo agora?
Sim.
Yes, they are back. Did you get my answer? So I will summarize it again. We have a sequencing stop every time that there is a halt in the Amazon. And it's time, that we talk to all carriers. If I have an interruption for 5 or 6 hours, that will drive a negative impact to the state of Amazon as well as Roraima. As to indigenous communities, we have a technical debt with them or to them. we were on indigenous community to go through with the cables, and we needed to get an authorization by the FUNAI, by their head of the community, and they said, no, there is no problem. And he said, we want to have a room with the 4 computers because we have native people in our community that they go to school in Manaus, and they have to go to Manaus because there is no internet, and I wish they could follow the classes remotely. So it's exactly the opposite. We have adapted with these people. They want to have digital inclusion, regardless who they are. If they live on a indigenous tribe, if they live by the river, regardless. Digital inclusion to everyone. Unfortunately, we have no more time. Sorry. Thank you once again.
Dando sequência, gostaria de convidar
Next, I'd like to hand over to Fábio Ardeola, who will talk about Sonic, which is a Linux operational network system.
Você quer usar o bastão? Sim, precisa usar o bastão. Deixa eu ver se eu posso. Tá bom assim? Boa noite, amigos. Boa noite a todos. Boa noite não, boa tarde, amigos.
Good afternoon, everyone. I am Fabio Ribas. In the next 30 minutes, I'll talk about Sonic. Can you all hear me all right? Who has heard about Sonic? Who has had a chance to set it up? We are going to talk about the evolution of network operational systems, Linux Foundation, Sonic and its ecosystem, Sonic and its analog system, its architecture, some case studies to conclude. Network operational systems. There are 3 models: proprietary networks, open networks, and open code networks. Let's start from proprietary networks. Are those where providers not only develop their operational system, but also the hardware behind it. Cisco, Arista, Juniper, Dell are some examples of providers in this segment. What are the advantages? When end user will get an equipment that will be optimized to their features and position in the network. End user is committed to that provider with little flexibility or customization. Now we step into the open network format, where 100% of all resources are based on operational network system, which is the proprietary one, over third-party hardware. Some providers such as Big Suite, Cumulus, and Viara. As to open network segment, Cumulus played a very important role as their suite, which allowed hardware layer such as WASIC from Mellanox and ASIC from Broadcom. Allowed automation. They were the first supplier to do it. Network open code installation. And they were also responsible for the FF routing. Open networks, they play an important role. And one other advantage is that end users, they are able to choose between hardware and operational system. A backdraw is that the suite company was sold to Arista, Cumulus by Envision, and Viara to Siena. But they are all available in the market. Open networks, they were very important for the coming next model, which is the open code model, where the network system is developed by a community, supported and developed by a community working with a third-party hardware. Open code network such as Sonic and Dent. What are the main advantages? End users, they are able to choose between the operational system or the hardware where that system will run. A backdraw, that system is supported by the community. Those network systems by themselves, especially if we are dealing with the open code systems, being an open code system is not enough for large-scale adoption. For that, many components are required and also to be in a collaborative environment, such as the Linux Foundation. And Sonic is part of the Linux Foundation since last year. This is a non-profit organization, and Sonic is part of this same NGO and responsible for the maintenance and continuity of this open network operational system. Sonic is part of the subgroup network on the right and also supports some other projects in the net. But it's not enough to be part of a community or being a open network. And it's also relevant to rely on a broad and robust ecosystem. Sonic ecosystem pillars are silicon, platform adoption, and companies which develop system and services. At silicon, equipments that come from Cisco 8000 family. Silicon One, they run Sonic. So the whole Cisco 8000, they run Sonic. Torica, Jericho, they support Sonic. Mellanox, they support Sonic. Intel, Tofino, they support Sonic. Platforms, the second pillar. This is where over 130 routers and commercial suites, they support SON. Third pillar, adoption. Several use cases. They started in the data centers, in the cloud providers. Retailers in the US, such as Target, they use it. Telco, such as the Gelco Telecom, ISP, such as Orange, as well as internet exchange, and Camel is an example of that. And to have a robust system, we will require services and companies. And to have an open code system at Linux Foundation and a broad ecosystem will not be enough to guarantee large-scale adoption. That's why many leaders that are responsible for network operations and infrastructures, they rely on analysts and developers such as Dockner and IDC and some results of their surveys. On the left, we have a hype cycle by Gartner 2022, and on the right, a hype cycle for enterprise network in 2023. On the left, 2022, we see open networking, and according to Gartner in 2022, the expectation of large-scale adoption for open networking would be around 5 to 10 years. 2023, on the right of your slide, we see Gartner removing open networking, including SONET now, as a synonym to open code networking. And Gartner expects that SONET will take around 2 to 5 years to reach a plateau of large-scale adoption. This is my last slide of the first part of my presentation. SONET has the power to become the Linux of network operational systems. Now let's proceed to the second part of my presentation, which is a little bit more technical, with the 3 brief demonstrations. So a Dell Cloud Lab setting, but I use some other environments, lab environments, but in addition to SONET and Dell, I like Sandbox by Cisco, which allows to learn more about SONET in the 8000 environment. If you have a GNS3, a SONET VM allows your lab. And yet, if you'd like to have a multi-sales lab, container labs can be a good idea. SONET's architecture that was created by Microsoft in 2016. It was a very simple, modern design, Linux-centric, and Docker container. It has a hardware abstraction layer, and SONET may run with different hardware possibilities. The platform system runs with over 130 suites available in the market, which may run SONET, and the orchestration ecosystem that may integrate to Kubernetes, Puppet, Chef, among others. Segregation of hardware and software, which is very important to anyone who is in the sector, as it fosters hardware innovation. Operational system, especially for open code, container-based, differently from monolithic operational systems. Here, a developer may run an app over Sonic. With that, we may add software innovation. And last but not least, orchestration ecosystem with frameworks and tools for open code. Now, our first demo.
Gravada, por facilidade na apresentação
It
aqui.
is recorded to make it easier for me to present it. I just want you to understand how we can configure that. For those who work with Linux, you see that the configuration commands and viewing commands like show can be invoked through Shadow Linux. This is one of the advantages of using Sonic. There are different ways of configuring that. You can update the configuration file, and then after the update, you can upload the configuration file and have it running in a memory. Commands are very similar to what you have in routers. It's similar in all types of features. And in addition to that, you can not only configure the equipment and visualize that using Linux commands, but there are also some frameworks that will be responsible for Dell distribution like Broadcom that will allow you to configure that closer to how you'd configure a router. So how do we invoke that? Using the sonic/CLI command. So you see that the environment is very close to what you would see in a router configuration environment. All features are available, such as interface, a port, IP address, routing, port channel, link aggregation, ACL, among others, so everything is very similar. So as you configure in a framework environment that was made available by a specific provider, in this case, Broadcom and Dell, you can change environments, and despite that, you will be configuring, working on the same configuration file. Show IP route, for example, this is a command you can use, and you can run the same command within CLI. That is part of shell that is invoked through Linux shell. So this is the end, my first demo. Let me move to the second demo.
Eu procurei mostrar algo diferente.
So here I'll try to show something different that would be working with containers. I chose BGP containers specifically. So here you can access the system through Shell Linux. You can use the configuration line for the container with the FR routing. Use FTY command, and you can see the router commands, and you can also use this environment for configuration purposes. In this demo, you see the configuration of BGP. It's very complete. It runs under different operating systems. And in addition to BGP, you can also configure static routes, SPF, just to name a few. It is important to mention that in this environment, since we are configuring a container that already comes with Sonic distribution, you can also replace this container. In other words, if you want to use FR routing, you can use Quagga. If you, for example, are running Sonic on PTX 10008 by Juniper, and you do not want to run FN router, then you can have the routing process, RPD, of Juniper, for example. And similarly, you could do that in an Arista environment using Arista's routing system for configuration. The configuration is saved in another file, but again, the visualization environment is this. You can view that within FR routing environment or even outside. You can have the BGP configuration outside as well. So this is the end of my second demo, focused on containers. Now I'm going to move to the third and last demo. I try to bring something new, something different, which would be the infrastructure container of the database. On the left-hand side, you can see a wider view of the Sonic subsystem. Here, you will see infrastructure containers, application containers, and the main purpose is to understand that this communication takes place through the database. It's a Redis database. It's the key value type of database. It runs on a memory and is very quick with very good performance. Here you can see the container of the database running. How can we access this database? First, you go into the instance. There are a lot of instances that are running at the same time within the operating system. Each one of them has different database with different purposes. This is the configuration instance. There are a lot of databases. And here on the terminal, you see the databases that you can see on this fast show. The configuration file, config.db, is a default database. Since we reached the first instance using Redis CLI, then select 0 for database, and then you can check what are the keys available in this database. Among these keys, we can see configuration of ports, of interface, of hot channel, or link aggregation, among others. So we run a command here, get all, and we do that on top of the Kavalan DAS key, and then you get the values and the state associated to this particular key. Now we're going to access the APPL LB database. If you like routing, this is the database where you see the routing table. And this is why I wanted to give you this as an example. It's not something we do on a day-to-day basis. So this is good for those working with telemetry. Access to the second instance is done through another door. Access to the database is done when you choose the database using the select command. We used all keys that are available in the specific database. This is where the routing table is. And this is a specific case, prefix 222/32. It's important to understand how we will detect the next hop. In this value, you see the value of next hop. So this is the end of this demo. Now I'm going to move to the end of my presentation. I will show you my last 3 slides. This slide is intended for those who are looking to go beyond the regular configuration. They want to interact with the Sonic system using SND. And you can use P4 programming language that allows you to have a direct connection with the data plan. And here are some use cases. I don't want to take too long explaining them. The first one will be one use case for a data center. Microsoft created Sonic and today has over 45,000 ports running Sonic in an agile environment. Another use case relates to Comcast and also companies like Deutsche Telekom and so on and so forth. LinkedIn, running Sonic on a LinkedIn environment. And there is also the Telecom Infra project. There are many projects that are running with Sonic as part of this major project. This is an example of a retailer, Target in the US. They run with distribution centers and stores all connected. For those who work with SPs in Brazil, here we have an example of Orange. Orange runs that in the production environment. So they run Sonic in the edge core hardware to aggregate some services. This is a campus network environment, another use case, internet exchange as well. Camel Network, for example, not only has all its environment running on Sonics and on third-party suites, but they also want to look in to run router service applications on Sonic. This is the my last slide, Alibaba's slide related to data center interconnection, just to show you innovation, especially related to the system. Well, this is finally the wrap-up slide of my presentation. I would like to thank NIC.br for the opportunity, as well as LACNIC for supporting our work through incentives. They are supporting projects conducted by Sonic Fabric, and also Intel is supporting us in applications on P4. If you want to follow us on social media, such as LinkedIn, here's my contact information. We are going to raffle some t-shirts later on. So I'm here available for questions and answers if you have them.
Fábio, muito obrigado.
Thank you, Fabio. Well, we've run out of time, but let's take one question. Thank you for your presentation, Fabio. I have two quick questions. From what I could understand, the CLI you mentioned is a Juniper-like system. If you're using the framework of management made available at distribution of Broadcom and Dell, yes, that's true. If you're not using that, if you're using upstream distribution, then this configuration module will not be available, and you would have to use a different way of configuration, show config and shows of Linux, or using orchestration tools like Ansible or other tools, because I didn't mention that, but Sonic can also be configured using OpenConfig or OSFull API. And another point, when you take a hardware with a given chip, just to mention a more specific feature, a chip that supports fetch on PLS. If you put Sonic on this equipment, will it work? Will it explore these features? Will it distribute labels and everything? So just the fact that you've put Sonic on one piece of equipment with a chip that has that feature, will that work automatically? What about FRR that takes care of MPLS? Today at Sonic's website, you can find more than 130 platforms, switches, and routers that support Sonic. So my recommendation to you is to first check on the website if this platform you may be interested in is included in this list. If it is part of it, then yes. And you see on the site there is an image available where you can use Sonic. Thank you. Thank you, Fabio, once again.
Obrigado a todos.
Thank you.
Posso desse?
Gostaria de
Esse é o meu computador.
convidar o Alejandro Guevara da Nokia
I would like to invite Alejandro Guevara from Nokia for the next presentation. Building multi-vendor networks with Container Lab.
Alejandro, por favor.
Bueno, muchas gracias.
Thank you very much. I'm sorry. I'm happy it was only the microphone and not the whole podium that fell down. Can you hear me? Perfect. Well then, first, thank you very much. I want to thank NIC.br for inviting me for this presentation. And let me also thank Fabio for his introduction to Container Lab. Thank you. My name is Alejandro Guevara, and I came here to talk about Container Lab. About Container Lab, we've been working with other tools to simulate network environments. So I usually enjoy starting with this phrase: having a lab is a privilege, not a right, because we use our labs for many different tasks as network engineers, especially for change management and to test prototypes, functionalities, new software releases. That is why we need a lab. And also for learning, a lab teaches how to use a new operating system, how to work with a new vendor. So these are the main reasons why having a lab is or should be a right, not a privilege. As I've mentioned, we had a few platforms on which we could simulate network environment. Many of you know this diagram. This is a platform many of you know. IBD. It's a tool many of us have used for network simulations. However, we wanted something more than this. We wanted to go beyond this. And so what did we need for our labs? First, we needed a structure, yes, a declarative format to establish our lab. So we borrowed this from IT, and we wanted to bring this to our network labs. Now, we also needed it to be Git friendly because this code and this lab had a certain infrastructure. So in our lab, we needed a tool for change management that could be shared also with other people in our team, and also for us to do change management in the whole laboratory. Then we also needed portability. This code or this tool had to run on any platform. So I want to run my lab in an Intel notebook running Windows or Excel. Another person can use the same code for the same lab on a different platform, such as Ubuntu or any other platform that can support a container. Also important is integration. To be part of the CI/CD pipeline, our lab must allow for us to be part of our CI/CD flow. And it has to be light, because we do not have lots of resources to generate this lab. So we have to be able to run a lab in our notebook, and that has to well represent our network. The other important point, which was already mentioned before during Fabio's presentation, We need open source. Our tool has to allow for us to use open source. I have already mentioned before, with all the benefits that we've mentioned, it also has to be easy to share. I'm working on a lab and then I need someone to collaborate with me. So I will simply share the code and we can have collaboration very easily. And finally, but also very important, we need it to be container-centric. As we saw in the previous presentation, everything now needs a container for transportation. As I mentioned before, our approach uses a number of different network tools. We make a number of declarations or statements in terms of resources that we need to use for computing, and this tool will deploy the whole infrastructure. We want to do the same thing at the network lab. So what do? We use a very similar format. I can easily interpret the tool and I can also use it to write code. And the tool will interpret these declarations, these statements we have expressed, and therefore it builds our lab topology. Now here, some pros and cons of traditional tools for network simulation and a comparison to Container Lab. If you have a platform such as Eve and G or GNS3, they were purpose-built and they're proven. They are feature-proven, and so they also have free versions. You don't have to make an investment to use the platform, and it has a user interface, a graphic user interface, which is an advantage, but also it has its cons. I mean, it's easy to deploy the lab. You just point and click to write the lines. However, oh, thank you, Fabio. Yes, we could not hear. We also, we could improve that for automation. And our tool is ready for that. Container Lab, what are the advantages that we bring to the table? First, let's support for containerized NOSs. We already support operating system images and other kinds of images. The other advantage is the transparent data path. We provide transparent communication between different network elements, which makes it very versatile, very easy to use. If you need protocol analysis, you can use a Workshark tool, and virtually you can capture the data that is going from one container to the next, as if you were doing real routing. The other advantage you have here is that the control protocols, such as LLP and SP, run transparently on the container data path. I have already mentioned that it is Git friendly or GIT friendly, and you have a better image sharing and handling. You know, this tool can be used multiple times, so it is easier to share the code so that other people can also use it. And as it is based on containers, we have a lower demand for resources in terms of processing or computing resources. And the disadvantage, but not so much these days, because as I mentioned, we have more and more vendors with network operating systems that have made available tools for us to, software for operating system based on containers. So earlier on, we could not emulate operating systems as you can do now. Well, but now we can. Also, we do not have a graphic user interface as Eve or GNS3. Now, for this presentation, I'm going to show you an example of IXP topology. And it's important to notice in Container Lab that this is a completely multi-vendor tool. Although it was developed by Nokia engineers, this tool can be used by any vendor. Now, in this specific case, we have a container based on OpenBGP, another one based on Bird. And in this case, oh, I'm sorry, one back. Let's go one forward. Yeah. So the other one based on Bird, and these two containers will function as route containers. And then I can use this LAN, the peering LAN, simulating ILX. So we have a Nokia SROS and an FRR, which is also a peer in this installation. Sorry. We have two VGB sessions between peer 1 and BGP, and also between peer 2 and Bird. Now, for us to be able to use Container Lab, the installation is really easy. You just have to run this script, which is available on our page. The only requirement is that you have, well, an operating system. It can be Windows WSL, Windows, SNS, any one of the platforms that you already use. Once you install Container Lab, it is ready for you to deploy your lab. Next. Now here we can see the declarations that I mentioned before. So this is used to create our topology. First, put a name on your lab. In this case, I'm calling it my lab. And then we will define the topology or the declarations that I mentioned. So very simply, I'm sorry, I am not using this pointer well. But first, we have to define the name and then the links. As we define the nodes, we begin from the first node, peer 1, based on Nokia's ROS. And so this is the node's name, but of course you can change the node's name. This one is SROS, and then the kind of image. You can download it from a repository or use your own images, and you have different versions of the same image. And if you need a license, then you can also subscribe for the license here. Now, having said this, now this Nokia has been declared, and you begin to see the topology. For peer 2, the kind of image, you can download it from the internet, and I've downloaded this specific image. Next, the route server. The route server, we've also downloaded an image from Linux with OpenBGP Linux. And for the second route server, we have also downloaded a Linux image with the Bird software. So now I have already declared my nodes. I have 4 nodes. And next, in this case, I have a bridge in the midpoint to interconnect this equipment. I will then declare another entity. In this case, it will be called IXP net, and this will be a bridge. After the interconnection, the other important thing I have to do in my topology declaration have to do with the endpoints. Here I'll say that peer 1 interface will connect to LSP, in this case using the cloud on port 1, and peer 2 will also connect with the ILXP port 2. And so now the topology is ready. Having done this, I will now go to my command line, and I'll use this command, container lab deploy -t, and the Yammer file where I have the topology definition. So it will build the equipment for me and also the connections between the different pieces of equipment. It's all set. Let me do something else. Container Lab also creates a management network for these pieces of equipment to have access to them or for management communication. And it also creates an IPv4 and IPv6, an entry on the file where we are running Container Lab, and we can use either IP or the name that was created by Container Lab, which makes it really convenient. And that's it. Moving on. I'm sorry, he said. How do we have access to the equipment? Some already have SSH, other equipment do not. So here we make the equipment declaration and we establish the access to that equipment. I also wanted to show you, if we look at the equipment and there's no configuration, again, we go back to Container Lab, we go back to the topology file, and we can use that as we include license and all that. We can also use an initial configuration file. So we can configure that from the beginning or when we deliver, when we have the lab ready. In the case of Linus equipment, we can actually do the same thing. The other thing we can do are binds. We can bind files running on the host or files running in the container, as we could do with Docker. It's very common on Docker. And so with Container Lab, we can also do that. Having done this, and you already have your lab deployed with all the equipment, you will have all the equipment pre-configured and interconnected, so you begin to have connections. Here we have access to Peer 1 via SSH. We can see the BGP table in this case. And BGP is right there on top because we have it pre-configured. What now? Well, we already have the lab, the limits, all the thresholds. We can use any one of these features we have here. In the case of IXP, we have the whole topology, all the information about this lab. You can have access to it using this QR code. You have all the code in Git. You can download that on your notebooks. You don't need any license. Everything is open, and these are the images we support today at the container level, but this is growing every day, so we're adding more names to this list. As a summary, I have already mentioned that Container Lab is a tool that takes this shape, the declarative shape. It's shareable, open source, container-based, light in terms of resources required, and it is very quickly and efficient to deploy a lab using Container Lab. We have lots of materials shared in our community, a number of labs that are already available. You can download them and run them directly in your machine. We also have the presentations available using the QR code. You can run it immediately if you want to download it. And again, we are very active in our community. We have the Container Lab website where you have all the information available, instructions for installation, etc. We have a Discord server, also SRI Labs for Linux Labs. And here, too, you can ask your questions after the presentation or here in Nokia booth. We will be around. Come and talk to us. Next week, as part of the NIC workshops, I will be giving this workshop on Container Lab on IPv6, and you're all welcome. So this is it for today, and let us now open the floor for questions.
Alejandro, Está ouvindo?
Alejandro,
Alejandro, temos uma pergunta aqui.
We have one question.
Uma pergunta do Ricardo e do Rodrigo.
Actually, we have two questions, one from Ricardo and another one from Rodrigo. They are both along the same line as they want to know about licenses.
I'm sorry, we have no sound at this moment.
Microfone aqui na frente.
Can you please turn on his microphone? Well, I can use this one. Can you hear me now? Okay, yes. So about licensing, there are some images that do not require licenses. For example, Linux, everything based on Linux requires no license. A few other examples I've shown here do not need any license whatsoever. You can use it and deploy it today. A few vendors do require a license, such as COS. Also, Nokia have a few images that require a license because of performance, but most of the images I've shown are open. They don't require a license.
Sim, temos uma pergunta.
Another question?
Se identifique e fale seu nome, por favor.
Please tell us your name and the company you are here representing. My name is Thiago. I work for Exa Networks. What is the level of the image used by Container Lab? I mean, the extension size. Is it compatible to Eve, INXP? We know that it's very difficult to find image sizes for lab use, especially for Huawei and some others. Are they compatible? Is it possible to import images from other labs?
Before I continue, I don't know where's Beto. Se me perdió Beto. Mi duende.
Está acá.
Ah, ok. Listo. No, es que tenemos un obsequio a la gente que haga preguntas.
Okay. Going to the second question. Of course, we can import Ibanez. This is a parallel project called BRNet Lab. We use the Container Lab page, reference it, and we take all the images that were in KBM, Q files, etc., and we take these, we import them with this project or an application, and we convert it into a container. And then we can then use it in Container Lab. So we take it into a container, we map the ports, and then we use it in Container Lab. Did I answer your question?
Yes, you did. Thank you.
No, ¿está bien? La única pregunta, lo único que tengo es una promesa que le debo a Fabio.
I have a promise to Fabio. I promised him I would talk about Container Lab. Yes, a little fluffy guy from Canada is here to tell you about this. But here you go. I promised this. I promised I'd stand up on stage like this. There you go.
Gracias. Vamos tirar uma foto do Feliz Navidad. Pessoal, gostaria de convidar a todos agora para o coffee break. Retornamos às 16h30. Muito obrigado.
It's coffee break time. We shall be back at 4:30. Thank you.
ok, perfeito. Isso. The notes here, right?
Yeah, it's not on.
Retomar agora as apresentações.
Let's resume the presentation.
Dando sequência agora às apresentações, vamos ter uma
So now we will continue the next presentation will be on Purine Toolbox by Fergus McKay from EuroX.
Hi, is this working? I'm not hearing anything. Or do I have to?
Yeah.
Okay. Okay. Hi. Good afternoon, everyone. My name's Fergus McKay. I'm Chief Lobbyist Officer at Flex Optics. I also chair the Fórum Program Committee at EuroIX, and I'm talking today about some work we're doing to enable easier peering for the enterprise community at IXs. EuroIX is about 70 IXPs, originally from Europe only, but now we have people from as far away as Japan and South America. We are set up in June 2001 when there were threats from some of the new commercial IXs that were threatening the community model that we had in Europe that had been very successful up until that stage. So we put together an organization and we created a board. I was a founder member of that board for a few years, and now I'm a patron and we support EuroIX through our work. EuroIX is funded both by membership fees for the IXs, but also from the 11 patrons we have who pay about 10,000 euros a year to be able to attend the 2 meetings that we hold, which is an opportunity for them to reach out and meet the IX community directly in a technical environment. So, moving on to the peering toolbox. This is aimed at the enterprise, not ISPs. So in many ways, we're starting from scratch, although people may know how to run their networks internally and do all of that. When it comes to actually dealing with the outside world, RIRs, internet exchanges, this is a completely new space for them. They've not played there before, and our aim is to guide them through that process. Traditionally, you would just buy transit. You'd plug your box into your ISP box, and it was a simple connection, and you didn't have to think. You did 198.162 on the inside, and it all just ran. But once you move to needing to improve the quality of your experience and the data relationships with your customers and suppliers, you need to start thinking, how can you improve that? Can you reduce latency? Can you improve reliability? So you no longer have a single point of failure when that one line to your ISP goes down and you're completely offline, both for your customers to reach and your staff to reach out. So any change, of course, comes with risk. As you change your working model and you're building new connections and new technical strategy, you need to have new ways of understanding your new relationships, because you'll have two kinds of relationships now. You'll have your relationships with the IXPs, where you connect, and then the relationships with the other members of the IXPs, where you do your private interconnections. And to reach that stage, you need to understand the environment that they all work in. And that's suddenly IP addresses. You know, you need more than one. You need to have an ASN. What's an ASN? For many organizations, this is a completely new experience. You need to understand what the costs are going to be. You know, previously you just bought a single connection, and now you're looking at connecting to multiple places, or one place, multiple people across that. You're having to look at interconnect rates within the IX. Do you peer on a root server? Do you what? You have no idea, because you're completely new to this. And this is what we're aiming to fix. You know, it's where to start, who to speak to, what are the best practices for doing all of this, and how do you now deal with network outages, because it's not a single point of failure again, it's lots of possible places. So about 3 years ago at EuroIX, we started working on this as an idea, and working with some of the larger IXs and Kentic and HEANet, the NREN in Ireland, we built a project which would provide this basic training for us as ISP type people, but for enterprises, completely new space, something they've never had to deal with before. And we're aiming to produce a best practice resource for them so that they can get quality information that's vetted and operational experiences, so they know what to do and how to behave, and have people to guide them through that process. So the toolbox we're building is to be a best of practice, best of information, and let people go to one place to learn at their own speed. So we built a website. It's quite in depth. I won't be able to show you very much of it, because it really is multiple sections with several layers down. But there's a lot of data in there that people can work through and pull the data that they need when they need it. It's easy for organizations to learn what they need to do in order to start on this whole new world of peering. And we have lots of experts working with us. Aside from, we also have IXP.db, which is the database that holds all of the data on all of the IXPs. So you can say, what's my local IXP? What does it look like? And PeeringDB, where you can do the same for who are the people who are close to me that I want to peer with. Do I need to go to a faraway exchange? Can I do it locally? So an early step was hiring Philip Smith, who some of you may know. Philip's been around for 25 years, initially at Cisco, building all their training material. He runs workshops around the world, and is recognized as probably one of the best people for training as an individual. He's created a with us, he's created a tool called peeringtoolbox.net, which so far has a beginner's section done. But all of the content from there pretty much comes from Philip's resources, because over the years, Philip has been documenting all the workshops that he's been running. So it's easy for him to say, we need to talk about this. Here is a content section that has been honed over several years. So it's not just fresh material, but it's material that's been peer reviewed, used for training in many places around the world. And there's a URL for finding the content on its own. Philip's site is very deep, so it's not necessarily the easiest place to find things. So the website itself, we've divided it up into 3 basic categories: beginner, intermediate, and advanced. So far, we've done the beginner section. We don't expect to get onto the next section until sometime middle of next year, and then the advanced section will follow from that. The beginner section is designed for people who are saying, my boss has told me we need to go to the internet exchange, and how do I do it, because it's now my problem. And we start off with the basics, because we know what the terminology we use, but people in enterprise don't. So it's, what is a network operator? Are we a network operator or what? What is transit? And what is peering? You know, things that for us are very simple because we deal with them every day, but as an enterprise you come in and it's gobbledygook. What's an internet exchange point? You know, I got told to go there. Why should I go there? And also a wider understanding of what the whole ecosystem looks like, because, you know, there are many different parts that we all interact with. We also explain things like the importance of peering and how and where to peer. What do you need to peer? You know, you can't do it with that single connection any longer. You need address space, you need an ASN. And then the politics of how do you get peering with another organization? Do you go to the root server? Do you talk to people individually? Do you go to peers for peers? What do you do to actually make those connections so you can widen your network? It's an example of some of the pages with both visualizations and words so that people can learn and understand. And you know, breaking down costs, things like this that are important to understand what the benefits are going to be, but also the risks. Because if you get into going to an IX and you have lots of interconnect fees, perhaps that costs more than the cost of your transit. You need to make a business decision whether increased reliability is better than paying money for transit. So that's a very brief overview. Just now we're always looking for feedback on the work that's been done. We're looking for volunteers to help develop it and provide guidance as to things that we are missing and we should add in, areas that aren't covered, and, you know, suggestions for improving it. You know, whether it's the color, the font size, the graphics that we use. So thank you for that quick overview. Happy to take any questions. Thank you.
Alguma pergunta para o
Any
Fergus?
questions from the audience to Fergus?
I think no. Fergus,
I don't think so.
thank you so much. Thank you. Agora, gostaria de convidar a Thalia.
Now I'd like to turn over to Dalia Maris from Meta. She's going to talk about infrastructure in the metaverse.
Tudo bem?
Acho que só tem que apresentar isso. Porque minhas notas estão lá.
PDF? Você pode jogar pro lado, é isso? Porque tá na outra tela. Sim. Graças a Deus. Pode ir. Sim.
Boa tarde. É que eu não posso ouvir, mami. Não. Ah, ok. Boa tarde a todos, tudo bem?
Hello. How are you all doing?
Trabalho na Meta no grupo de infraestrutura. Vocês me escutam bem? Sim? Ok. Eu trabalho na Meta no grupo de infraestrutura.
Yo trabajo en infraestructura.
I work in the strategic management, Mexico, USA, and Canada. You all know what Meta is, so there is no need to tell you what we do, right? I am from Peru, but I have been living in the United States for a while, actually for many, many years. I'm learning Portuguese. I apologize for my accent.
Espero que todos puedan entender. E no final da apresentação, vocês poderão fazer...
By the end of my presentation, you'll be able to ask your questions.
Hoje, nós vamos conversar pouco sobre o que é o metaverso.
Today, we are going to talk a little bit about what metaverse is, and I'll give you an overview and our perspective in a long run. So let me share a little. Facebook Messenger, WhatsApp, they count on 3.5 billion users monthly, 50% of the global population. And our goal is to connect people to their family members, friends all over the globe. And the sort of content to be shared has been changed. Now we see a clear trend in a technology switch. In the past 10 years, text, photos, videos, they have been changed and now they are getting into a more immersive content, such as augmented reality and virtual reality. What is metaverse then?
Ok, bueno, voy a explicar o que é o metaverso, o vídeo não funciona. O metaverso é um conjunto de espaços virtuais.
Metaverse is a set of virtual room where you may explore with other people what you cannot reach physically. You may play, go shopping, play, and much more than that. It's not a matter of replacing on-site experience, but to turn whatever we do online in a more effective and meaningful way. You are gonna feel that you are much closer one to another, as if you would take someone from one place to another. It's like a teletransfer, augmented and virtual reality, or a combination of both, a hologram, smart cities, and more important than that, that's not going to get at once. It's going to take step by step in a long run. This is a current experience that we have available on a better format for virtual reality. Let's see if I can run the video. It's running slowly, so I'll keep talking. What latency makes for great metaverse experiences? First, you may watch live video on demand. Experiences such as workroom, Facebook gaming, they will require lower latencies between 50 and 100 milliseconds. This is the required latency for fast interactions. Holographic images, they may need the latencies which are slower than 1 millisecond.
También es importante decir, esos números son presentados pensando en las conexiones de usuarios.
Well, figures, they take into account users and providers, which is not necessarily the goal for the use of metaverse. Our goal then is to connect people to people. This is our framework, and how can we support the new features and conditions? How are we evolving our infrastructure? But first, let me introduce you our infrastructure components. What are them? We have 20 data center regions where we have the origin of our content, 80 or more edge pop markets. And we have over 7,000 in-network cache clusters. They help to deliver video and image content and over 8 billion users using metaverse apps. To reduce end-to-end latency requires breaking down the components to identify opportunities. The first one is the ISP network, can be a fixed or mobile network. They connect to the edge POPs, where we have a peering connection or IX connection. The void network is connected to the content origin. Connections, they use international backbone, which can be rented or proprietary. Additionally, we have the caches, where we deliver static content, images, videos, among others, and we deliver content to reduce the national backbone. This is how we deliver current experiences. How about now? New experience, they may increase personal-to-personal experiences with more latency and greater broadband. An example of non-metaverse experience that requires edge infrastructure. A user who is in the phishing network, and it is an Instagram user. Pop Edge. Pop, they supply dynamic content, users, interactions. We have POPs in São Paulo, Rio de Janeiro, Fortaleza. Next, that will be available in Porto Alegre and Brasilia, our federal capital. They are delivered to users as long as they are able to offer the best user's experience. They also guarantee a better user's experience. A more interactive experience, which is a game. Super Rumble. This is a game that can be rendered or applied in virtual reality in 2D, 2 dimensions. For that experience, we add graphic design together with the ISDN infrastructure. This is a dedicated computing to guarantee renderization of content. We also have CDN flows for content combination, where we have the origin component via backbone. We have some challenges, such as offering services that will have a higher broadband among users while we render content over the network. How can we improve it? With local infrastructure. First click, add a more local infrastructure. We install it much closer to users. Brasilia is a hub which is being tested for next year, and they're gonna have that already installed. Traffic flow will be taken from a faraway node to a closer one. Traffic flow will take a render content such as GPUs, and the closer nodes will encompass both devices. Some markets will centralize content renderization by implementing caches.
So esos puntos más próximos conectados en esa red por nos.
closer points, they are connected by nodes. We request consent authorizations. We are the ones that connect to our own network by the cache. That's how we expect to expand our edge infrastructure to other countries throughout ecosystems, connection and infrastructure. We are dealing with the secondary and tertiary markets, not only in Brazil, but all over. Scale. The higher you are, the furthest you'll be. So we have to involve users, origin services of a database where we have million servers. Edges, we have several servers present at the largest appearing markets. That is a mix of CDN and GPUs. Caches closer to users, they amount to 7,000 clusters where they are located at the GPU, CDN networks, CDNs and GPUs together at secondary and tertiary network levels. And they are much closer than the edge POPs that can just work and support CDNs. What are we doing? Well, we have increased the presence. Here you can see latency all over the country. The lighter the color, the lower the latency. Moving beyond the dedicated cache appliance to full edge enables more services at higher quality for more people, like the ones you have here in Brazil. Also, high-density secondary markets, deeper into regional network presence, aligned with ICP aggregation points, reduces backhaul needs for ISPs. It fosters new or existing carrier-neutral colocation ecosystems for topologies like that, and ranked on impact and marked readiness to our products and market development. And to close, we cannot do all of that by ourselves, otherwise it would take ages. There are some other aspects that can push ahead the next phase of feasibility. It has to be an open market, such as the internet. The provider, the carrier will be metaverse. It has to be a collaboration across industries, built on proven principles, internet ecosystems. Also, it has to attract, it has to be attractive for investments and an economy which will make sense to all. It has to be scalable and green. It has to be sustainable. Applied design is to be replicated at different settings. If we have a zero net carbon free, to have a shared responsibility. That's it from my side. I don't know if you have any questions. Thank you, Thalia. Are there any questions to Thalia? I have a question myself. You've mentioned that Meta aims to open services in Brazil and Porto Alegre in a short run. Anything else? Do you have anything else in your, on your track? Porto Alegre will come first and then Brasilia. Thank you for your question. Yes. Next year, next January, we will want to have our CDN POP in Porto Alegre. We see Porto Alegre as a huge potential for developing interconnection CDN systems, and we are ready to kick that on. In the second half, we are going to install CDN POP plus Edge Cloud. That will be the first POP with the GPU activation that will be released in Brasilia. After that, we are going to have GPUs in São Paulo and Fortaleza. These are the first markets that will be able to carry out content renderization. There are some other markets with good potential, but they still need to improve their infrastructure. Connectivity is key, but the most important right now is to understand each one of the markets, how they are going to, leverage investments on secondary and tertiary markets. Thank you. Thank you for your time and patience.
Não, it's okay.
Muito obrigada pela presença. Esteja à vontade.
Pessoal, agora na sequência teremos a apresentação da.
So now we will have a presentation by Camila Carvalho and by Claudinei Soares from Global. They will talk about the journey of creation and evolution on one of the largest CDNs in Brazil. So Claudinei and Camila, please join us here at the stage.
Pode falar daqui do móvel, como vocês quiserem. Acho melhor o móvel. Bom, pois não. Então, vocês dividem o móvel para baixo.
Olá, boa tarde a todos.
Hello, good afternoon. My name is Camila Carvalho. I am the leader of the InfraCDN squad at Global. I've been working at Global since 2018 as project manager and infrastructure product manager. This is the first time that I'm here at this forum, but Claudinei is an experienced participant. It's important for us to talk about the improvement of quality of Brazilian internet. We want to talk also about partnerships and connectivity. I'm Claudinei Soares. I am the peering coordinator and expert at Global. I will talk about peering, connectivity with Global, how you should connect with us, and open for questions if you have any questions on how to connect to Global Platform and CDN. We have prepared the presentation that will focus on talking about what's new about Global CDN network, especially about our expansion in the Brazilian territory, some important quality metrics based on the latest events of the past 12 months, and what Globo is betting on in terms of events that are going to be held in the next year. We're also going to explain to you how we can interconnect with us using our peering points of presence. We also would like to give you an update on our capacity, the evolution of the routing solution of Globo, show you some details about this new routing solution. We'll also share with you some frequent questions that we are asked, but feel free to ask any other questions on the solution itself. Global CDN is present in all capitals of the country and 21 other locations with connections on PPTs. We expanded to 24 PNI points, which is our private peering point, and we can connect to layers 1 and 0. We've also reached an important landmark, which was the launch of 260 points of presence, POPs. This year alone, we launched more than 100 POPs through our global cache appliance, which we call GSA, which is basically the cache server infrastructure of Globo implemented at the sites of our partners, the carriers or the operators. Our capacity allows millions of internet users to connect to us simultaneously using average bit rates of great quality. We've launched a lot of content in 4K. Content and consumption has increased, and this requires global CDNs a great capacity to absorb all these changes. So this is about the last 12 months, 3.5 billion hours watched, 2 billion hours in live streaming alone, 11 billion plays, of which 3.3 billion in live streaming. And last year, we talked a little bit about the World Cup. Last year, this was an event with a huge audience. We wanted to reinforce our points of presence for peering and GSA as well. And this year we had a new peak of 2.9 million users simultaneously during the game, the soccer game of Brazil against Switzerland. And the average bit rate was very high. We've also reached a recent peak of bandwidth when Brazil played against Argentina, 56 terabytes of data transmitted in 1 minute. That's also very relevant with an average bit rate of 3.8 megabits per second. This was a game broadcast in 4K, so in high resolution to the whole country through Global Play, which is our streaming platform. All of that delivered with low latency, under 20 milliseconds, a join time under 5 seconds, and a buffer ratio under 0.5%. And when Brazil played against Argentina, the IX of São Paulo, only there we were able to reach 1 terabit per second when this game was broadcast live. Also, here are some highlights for next year. We're going to have a lot of events in 2024, such as the Olympic Games in Paris, the first Olympic Games after the pandemic. So we expect to have a lot of attendance here. We are going to have a booth there of Global. You can reinforce peering, you can contact us to reinforce our GSA points so that we can improve quality. All games are going to streamed in 4K live at Global Play platform and in other channels. Such as in the World Cup, we expect very high audience levels, but widespread. We expect people to watch between 9 and 8 and 6:30 p.m. and those games will take place between July and August next year. Big Brother Brazil is a very important show in Brazil that has increasingly reached new peaks of bandwidth, new peaks of simultaneous watch. And next year, we expect nothing different. We expect new things about this show. with new cameras. We're going to have new attractions. A new voting system is not going to be streamed in 4K, but 24 hours live, and it will start in January. Finally, we like to highlight Rock in Rio Festival 2024 that is celebrating 40 years of existence. It's also going to be broadcast in high definition. We expect a lot of people to watch that. And since it's its 40th anniversary, we expect a lot of people to watch it. And also because it's going to be broadcast in high definition. This is going to take place in September. In addition to those events, we also have the Lula Palooza, Carnival, and some games of the Brazilian tournament, soccer tournament, that were transmitted in high definition this year. Next year, we are going to have even more consolidated type of broadcast using high definition. Now I'll turn over to Claudine. So let me talk about peering. Peering is a very important part of our infrastructure and of our growth strategy for CDN because it's good not just to increase the widespread of our connectivity, so we'll connect with more operators, but also with operators that have cache. So for the cacher that is remote, that's a very important part of our structure. We have some peering possibilities. When we go somewhere where we can use our switches with peering connection capacity, then we can go to these locations directly to the IXBR of that location where we can connect to several ISPs at the same time. Then we can establish an opportunity for ISPs and each will connect the best way possible. So we can make direct connections, as you can see, PNI connections. ISPA will make a direct connection with a global switch, or maybe this ISP could have a direct connection with IX or PNI. So there could be a redundancy by doing so. Where we have tier 0, we deliver 100% of the content. On tier 1 and tier 2 locations, we deliver about 90% of the content of the video platform. And this is based on the number of views, not on the catalog, because our catalog, just 5% of our catalog accounts for 95% of our views. This shows how important capacity is. You can connect to Global using IX very nicely because Global is concerned with connection capacity. Today, we have 1.6 tera of capacity at the IX of São Paulo. It's a good capacity. Our record was a 1 tera in the Brazil-Argentina soccer game, and we hope that we will reach new peaks in the future, especially during the Olympics. We have our strategies planned. So if it's close to 1.6 tera, then we can increase this capacity very quickly. 800 giga is what we have in Rio, 400 giga in Fortaleza. And in some cities, we also have a strategy in place to increase these capacities if necessary. This is one of the most important points that relates to connections in different regions. Global is investing in this connection through peering because of the regional I-axis. When we started on this journey, we could only connect with the 10 giga interfaces, but today we have 5 locations where we are connected with 200 giga capacity. In Florianopolis, we are just completed this expansion last week, and there are 4 places where our connection reaches 80 giga. This shows that we are growing in terms of regional I-axis and their capacity. Not long ago, it was in so significant compared to São Paulo, but now in total, the total amount of capacity of regional IXs equals to what we deliver in São Paulo. Globo participates in the PCDN project both in Salvador, where we have 80 giga of capacity, and in also the same in Manaus at the Open CDN project. So these are two possibilities of connecting to Globo in other locations where we cannot do direct peering. Where we can use PNI, there are several capitals around the country, several cities, not just capital cities, but where we can use PNI. We have made investments in cities where usually investments would not be made, like Cuiabá, Goiânia, or Londrina, São José do Rio Preto, which are in the countryside, Campinas. In some of those cities, we believe that there is potential for growth. In Natal, for example, we believe that we can grow even more in that city. And we hope that more people will connect either through IX or with direct connections with Globo. Now let me talk about user directioning, and that's part of the algorithm, as Camila mentioned earlier. We deliver our platform based on BGP and geolocation in this order I'm going to describe. The first criteria relates to a more specific prefix out of all the locations where users have visibility. Where do we have a more specific prefix? If the prefix exists in more than one location, we use then the lowest BGPAS path. And then we choose the shortest geographical distance. Then we'll have a list of the best POPs. We take a list of 4 POPs, the 2 best ones plus Rio and São Paulo, and then we choose where users are going to take the content from. If it is available the best POP, then you take it from there. Otherwise, it will take it from São Paulo or from Rio. Because São Paulo, there's 100% of content. POPs tier 1 and 2 have about 90% of the content, 3 and 4, 80% of the content. We also analyze some requirements for access, such as network capacity of the POP, latency, and so on. Here are some frequent questions. First, how can I see what is the best POP that my user can be directed to? We have browsereport.global.com. It's a tool that has been specifically developed for that, where it's possible to see visibility of where I am, what is the geolocation used by Global, the specific IP, and what POPs have visibility, the size of the SPF. Can I prioritize my connection through OpenCDN versus some transit? And to do that, you need to manipulate BGFPS. And if that's not the case, if you follow the regular criteria, then you just follow the criteria BGP ISPF, then visit pet location. So suppose that my prefix is being detected in the wrong geolocation, what can I do? Well, you need to get in contact with our access provider, which is our Maximind, which is our geolocation provider, and ask them to change the geolocation. Oftentimes this happens, they need to change the geolocation. About CGNet, Global does not work with CGNet. So if your network is based on CGNet, we recognize the IP of the platform. And about IPv6, this year there was an improvement because all servers are being installed with IPv6 support. But the platform is scheduled to be updated in 2024. Here's more information about some main contact points. Our help desk, complaints, troubleshooting, peering. So you see different points. NOC network information for those who have direct contact with Global. We also have the peering page when you can request peering, the GCA page when you can request GCA, and the troubleshooting page that I mentioned before. Thank you very much for your attention. Do you have any other questions? Okay, any questions to Claudinei or to Camila? I have one question here, Claudinei.
Que recebemos no chat do YouTube.
This is a question from YouTube chat. Do you expect to increase IX in São Luís in the state of Maranhão?
Eu vou voltar a pergunta para o Galvão. Tem previsão de porta de 100 GB no X de São Luís do Maranhão?
So I need to ask him, I guess.
O Júlio comentou de manhã,
Julio mentioned in the morning
analisando caso a caso, né?
that we are analyzing each case. In addition to Rio, São Paulo, and Fortaleza, we're also analyzing each case, and we've done that, as you mentioned, in Florianópolis and Recife. Yeah, we can take that into account. So, can analyze each case, yes. Well, that's the answer. If there is demand, we are ready to expand in all locations. We can expand to 100 giga. In some cases, we can expand to intermediate capacities like 40 or 80. Yes, and we can analyze traffic in São Luís also to see if it's time to expand. Any questions? So please identify yourself and the company you work for before you open your microphone.
Agora sim. Meu nome é André, eu sou da CGI Networks.
I'm André, I'm from CG Networks.
Sobre o IPv6 que foi mencionado no
About IPv6, you mentioned that towards the end of your talk. You mentioned that you expect to implement that in 2024. Do you have a more specific time in 2024, a given month? No. This is a project we should have started in 2023. So trying to prioritize delivery in IPv6, but there are still some open points that we need to analyze to understand what part of the platform could have problems with IPv6. So let me give you one example. We depend a lot on the geolocation database, that the ones we use today. They are more accurate in IPv6 than IPv4 than IPv6. So we need to improve that. It's not a barrier, but we will need to deal with this problem while the IPv6 database is not so good. We need to implement some solutions to improve the detection of the geolocation. Okay, thank you. One last question. This is also on the chat of YouTube. Renato Moraes asks, any expectations when we are going to have bypass to CGNet? So, like some people announce for specific communities with specific prefixes? No, we don't expect and to have something like that, no study in place at this point. Well, one final question, but I'd like to comment on that. I don't know if you mentioned during your presentation about the future locations where you plan to open new locations. Ricardo Oliveira is mentioning Rio Branco in the state of Acre. Well, we don't have that planned yet, any new locations, except for GSA and Tier 3 locations. but we don't have any plans to have any new POP for 2024. But depending on the growth of each location, of course, we can study that. When we start the Open CDN project in Rio Branco, we can use that project to start it. That's a strategy that we are considering for some cities like that. Okay, thank you very much, Camila and Claudine.
Na sequência, gostaria de convidar a Tatiana.
Next, I would like to hand over to Tatiana Curi, who will talk about IX remote peering.
Uma boa tarde a todos os presentes.
Hello, good afternoon. It's a great honor to be in Brazil. I live in Holland today. I work at Amsterdam Internet Exchange. I am Tatiana, and I'm so glad to be here to share a little bit about remote peering. And I would like to thank NIC.br for the invitation. Not a while ago, a survey was conducted to know how long people spend at the web in each country. And we all know that Brazil is ranked in the top 5. Brazil is one of the countries where people would spend more time surfing the web. Here we are just ranking behind the Philippines. Actually, we are ranked in second, and we are just 1 minute ahead Colombia, who comes in third place. Our daily internet use is 40% higher than the world average. This is a very significant table to let us know how important internet is in this country. We have increased so much the daily time spent using the internet and the average amount of hours comparing other countries. This is a study carried out by Telegeography, and the most updated chart shows in dark blue. As of 2021, they used international bandwidth in Latin America, and their forecast, what they expect to be achieved by 2026 in light blue. And from 2023 to 2026, the international bandwidth use will increase even more, threefold higher in a short period of time, just 3 years. So what is the relationship with the remote peering? People, they are spending more time in the web, and they have access to exclusive content. Remote peering. What is remote peering and why? Unfortunately, the world content is located at different places. Some content that you won't have access in Brazil, but that you would if you were in Amsterdam. So content, international content somewhere else, now you can have that available to your end users. Remote peering. is thanks to an international VLAN, you may have access to that content. By expanding opportunity to Brazilian internet providers throughout exclusive content access. Roblox is not yet in Brazil, but it is in Amsterdam. And my father, who is 75, he plays with my daughter, who is 9. They play Roblox. I can't, but they can. And we know that a breakthrough in the internet was that people, they became much closer. So, and that's a time when grandpa and grandchild, they spend some time together playing. It's great. Exclusive content access, by that I mean video streaming, game, IPTV, among others. Remote peering access, as the name says, that is done remotely and can be done throughout some partners. Many Brazilian providers, not just in Brazil, but at some other Latin American countries, they are already remotely connected to AMX IX, and there is an increased demand for European content. Remote peering is easy and can be, and its configuration can be done fast. Remote peering would require a data center in an international point of traffic. You would need to have a racker in an international company to have an enterprise abroad. All that bureaucracy would be necessary. People would be hired to work in your international office. But with remote peering, you don't need a presence point, no need for hardware, there is no need to invest in new equipment. It's fast and you gain new partners. Who are our Brazilian partners? Angola Cables, Pier 1, PCCW Global, Telxius, and Vital. If you benefit from partners to have a remote peering access, that helps you with flexibility, and you are able to choose how much to start with. You may start with, let's say, 200 mega, and then you may, see what will be the level of frequency, and then you may switch to a different contract, and you'll be able to manage yourself together with your Brazilian partners. So there is an emerging wave. Internet will keep on growing, as I showed you in my first slide. I guess that Brazil very soon will be ranked in first for internet daily use. A while ago, Brazil was ranked in 7th, and now we are ranked in 2nd. So, very soon we might be running in first. And how can we differentiate from other players in the market? And a way to differentiate ourselves from the competitors is by offering exclusive content, and remote peering will allow us to have direct access to content, what can be very helpful. Your AS increases the content performance. If you have any other questions, just get in touch with me. Thank you for your attention, and that's it. I'll be here all day tomorrow at your disposal. Thank you. Thank you, Tatiana. Are there any questions to Tatiana? Let's see if we got any online questions. No, not now. Thank you.
Na sequência, gostaria de convidar o Darwin.
And to close the day, we have Darwin Costa from D6. He will address new route linking Europe and South America. So this is going to be the last presentation before the beer and gear session. 10 minutes to wrap up. Hi there, good afternoon. Well, mission impossible. I'll try to be very brief so we can run for the beer. We are a Brazilian carrier that was responsible for the new route connection between Europe and South America. I am Darwin Costa. I work for D6, which is a company founded in 95 in Frankfurt. We operate over 50 PPTs. I am also the founder of Angola Peering Fórum, where we had the pleasure to welcome several colleagues from NIC. And if there is anyone from Brazil or from South America who'd like to participate at our forum, just get in touch. So I will briefly give you a brief history about the internet, new hubs and routes, measurements, Q&A, and then the most important part of the day, the beer and gear. Well, Demi has shown us this slide. This is very nostalgic. This is the ARPANET logical map. And here, United States map in the middle of 2005. In the US, which is a country of large dimensions, as large as Brazil, where they have several habits already developed and major carrier hotels acting as connectivity hubs at that time. That was the international landscape. Those who didn't have a chance to visit the United States, I illustrate here the so-called carrier hotels. I have a picture of the major data centers with the several floors, collocation, a little bit different from what we see in the data center world, but that's how they work in the US. New routes and hubs. Who would remember about the Atlantis II, the submarine cable system? Douglas, for sure, Douglas. The submarine cable system was ready for service RFS around the year 2000. It's no longer operating, but that was a system that would link African countries to South America and later on to European countries. They used the RIPE probes we used the probes and European IP, the traditional route, and now the new one. We assess the route and the latency of the trajectory. Traditionally, the red route, 210,000 milliseconds to go from Brazil to Frankfurt, and the yellow route, much faster. No, before that we have the white route, which is the new route from Brazil to Portugal or Spain with a much lower latency than the red one, and the yellow route going straight from Brazil to Frankfurt without a stop in Portugal. 89 milliseconds. That is critical for content or for carriers if you have a content which is not yet stored in Brazil but in Europe. Latency is the new currency. New generations, before they would be happy by discovering something, but not anymore. You know, they are always in a hurry, and latency became so critical. Talking to someone on the plane from Holland to Brazil, a Brazilian guy working in Sweden, he told me, you know what I really miss is to play on a server in Brazil with my friends. I no longer can do it. What is your latency? 350, 400 milliseconds. Well, that's impossible. He cannot make it happen, can he? I'm not Brazilian. I am from Angola, but if I were Brazilian, I would be so proud of Fortaleza that is becoming a Brazilian hub on the rise. If I'm not wrong, Fortaleza has surpassed even Rio de Janeiro. But the world is very alert to the Solines development. In Angola, we had a cut of 3 submarine cables, and it took a month for them to be repaired. If it were not for Fortaleza, probably our country would be totally with no lights, totally blackout. But thanks to Fortaleza, the cables were taken to Angola. The latency was no longer a problem, but at least we were connected. Measurements. We got an IP in Spain, and we followed the traditional or the latest trace route. Over here we have 17 lips, and on the other image just 2. Traditional route versus the new one. On the 5th lip, we have a Brazilian carrier, and now with the new route, it's the same. We see a package. And since, as of the 6th lip to the 14th one, the Brazilian carrier delivers the packages to an entity which I am not mentioning the name, and the content can be delivered after 14 lips versus the new route that finishes in Spain, Madrid, then Barcelona, 237 milliseconds versus 151 milliseconds max. Huge difference for those that are willing to increase their quality of service to Brazilian users. Here you can see the red traces and the trajectory, the route that the packages took until they have reached Barcelona. in Spain. Next to Barcelona, we got a probe, and in Brazil, we got another one that was between Minas Gerais state and Espírito Santo state. When Brazilian internet carriers, they realized the level of the level of the service delivered, the quality has been increased as well as latency, and results consequently were much better. That was the first time that that has been disclosed in the social media. Until the 11th leap, the package has reached Madrid and later to an entity called domdominio.com. You can read the comments yourself, but users, they have commented that there was an increase in the quality of services delivered. So link to RIPE, there are some already in Brazil. If you want to store your own RIPE, you may talk to Flex Optics to store a higher number of props in Latin America. Those of you who love submarine cables, you'll be able to search for old maps. Questions and answers? Well, let's save them for later. Thank you. Are there any questions to Darwin? No, not now. Thank you, Darwin.
Você me dá o microfone aberto? O microfone aberto? O microfone aberto. Oi, pessoal. Boa tarde. Queria deixar alguns avisos aqui. Agora vamos começar o nosso tradicional Beer and Gear.
Unfortunately, we cannot hear his mic. The audio is really, really bad, but he's talking about the beer and gear. You may also get your cap and t-shirt outside. Thank you and see you all tomorrow. Enjoy your beer.